Leet code 257 binary tree path. This is the problem. I take the code from his video in here. I'll provide the link in the description. I already copy or rewrite it in the IntelliJ IDEA. This is on the previous take. I don't want that. I want to show you that this is the original input and this is the result, but I found that this is not enough for me to understand, so I modify it to add more value in here, and this is the tree. This is the sample and this is the original. To the left I add 7, to the left of 2 I add 7, to the right of 5 I add 9, and to the right of 3 I add 10, and to the left of 10 I add 12. So I kinda know how does the tree kinda traverse, and that makes me help me better to understand. Let me delete this one. We don't need that anymore. So we go back to the code in here. So I put a breakpoint in here, and also breakpoint on the left and right and in here. So at the beginning, when left is not null, when right is not null, and at the current DFS path, helper method. Let's debug it. So when we debug it, we already input the root with all of the things in here, and it's shown in this root. I don't know what does P mean, but in here we have the root value of 1. To the left of 1 is 2, to the left of 2 is 7, to the right of 7 is 5, and to the right of 5 is 9. That is exactly the same as we have in here. 1, left 2, left 7, right of 2 is 5, and right of 5 is 9. Then we also have the from 1 to the right of 1 is 3, and to the right of 3 is 10. So the information of the root is recorded in here. One note is that Leet code provided this class, which is like public class tree node, and you have to create that in your IntelliJ IDEA as well as the one as I created in here. So it take the value of left and right, so we can store it whether it is left or right, and when it's val, it will return the val. Pretty much that. So right now we create the result, which is list of string. What is an array list? What is an array list? A list of array that can we keep add and add and add. In Java you have two. An array that cannot be added. Is that primitive or not? I'm not good at that. And the one that can keep added. So we keep added because we don't know what will be the end result, as long as it will match the condition in our code. First of all, at the line 9, do we even have the tree or not? Yes, we do. Therefore, it's false. So we can continue. This is to check whether we have tree or not. So current path, right now, we start from the root. From the root, we convert that into a string from the integer. So this is 1. We convert that into the string. Voila, this is the string. Right now, is this the end? Which means that root.left equal null and root.right equal null. If both of them are on the end, which means that we are on the leaf, then we just add that result. We are done. However, we still have the left and right value in here. Therefore, we will go to the line 13. And if the left is not null, we call the helper method of DFS, taking value root left, taking argument root left, current path, and the result. What does it mean? In here, we have argument of tree node that we call node, string that we call current path, and list of string that we call result. The current path right now is the string that we also initiate in here, and right now the value is the string of 1. Plus equal, which means like we keep adding it in every iteration with this arrow. That is because Leet code wants us to write that arrow in here. Plus note that file, that node is in here, and we take that from the root.left that we assign or like pass on in here. So right now we have the current path is 1, and after we execute this code is 1 arrow plus note that file is 2. So the string of 1 arrow 2, that will be our result. See that we have in here. And check again, are we at the end or not? If we are at the end, which means that the left is equal null and also the right is equal null, there is nothing more on the left on the right. So we will add that to current path and return to the code in here. If not, we just keep going to the left. Here we call it recursively. When the left is not null, we call it to another left. What is the left of the 2? The left of the 2 is 7. So we go to 7 in here, 1 arrow 2 and arrow 7. Okay, right now we are at the node 7. We don't have left and right anymore. So you can see in here, we don't have left and right anymore. That is null, and we will add the current path to the result. So right now result is array list of 0. We have nothing there, and we add that to the result. That is our first result, and we return to the above statement. We will return to the statement there. So we're done with the left right now. And where were we? So we are done with the 7 in here. So from 1 to 2 to the left of the 7. 7 has null. When it has null, we will go back into 2. This is eraser. We go back into 2 and we are going to check to the right. Okay, 2, and we execute the line number 28 in here. We go to the right. So we were at 1 to 7. We're going up to 1 2. Therefore, the current path right now 1 arrow 2, and we go to the right. We have the value of 5. Current path is 1 arrow 2 plus the arrow plus note that file. Our note that file is 5. So it will be 1 arrow 2 and arrow 5. That's it. Is there any more number on 5? Yes, we have 9 to the right of 5, right? And therefore this is the right is false in here. Okay, cool. So we will not execute the code in here. We'll just jump to the line number 27. Number 27, left is false. We will not execute anything in here. And the right is true. When the right is true, we run it, execute it recursively, the DFS, take the node right, current path, and the result. So right now, our current path is 1 arrow 2 arrow 5. Our node.val is 9. So 1 arrow 2 arrow 5 that we have in here plus arrow plus 9. You can see that is I don't know if you can see that. Yeah. That will be the result for both of that, and it will be 1 2 3 5 9. Okay, cool. Right now we are at the node of 9. Do we have something on our left? No. Do we have something on our right? No. So we just add that result to the current path. So 1 2 5 9, and we return. Okay, so we are done in here. So we were at the 1 to 7. We record that 1 to 7. We record that. We return to 2, which is like you have in here 1 2 and then 5 and then 9. So we already examined 2 on the left and on the right. So from 9 we back to 5. 5 we back to 2. Have we checked both of the left and right value of the 2? Yes. Therefore we back to 1. We already checked the left value of 1. Right now we are going to check the right value of 1. That's why in here we are at the current path 1 and we at the line 14 check whether the right is not null. Number 1, right is not null. It has the value of 3. So we will run the DFS route to the right. Okay, we are 1 right now, and the node that file is 3, and it will be 1 arrow 3. Yes, we have that 1 arrow 3. And is this the end, the leaf? No, we don't have anything on the left, but we have something on the right. So we'll just go to the right. Therefore, we just we will not run the line number 27, we just go run to the line number 28, and we go to a second recursive. And the second recursive, the value is 10, and we have current path of like 1 arrow 3, an arrow that we have in here, and then 10. So 1 arrow 3 arrow 10. Okay, cool. Do we have to the left and to the right of this 10? Yes. The left is not null. We have something on the left. The right is null. So since this is n, so 1 is false, 1 is true. So it will return false. So we will skip the line 23, 24. And then we jump into line 27, we go to the left of number 10. When we go to the left of number 10, we will have the value of 12. This value 12 will be added to current path. Our current path right now is 1 arrow 3 arrow 10, and it becomes 1 arrow 3 arrow 10 arrow 12. At the arrow 12, do we have something left to the left or to the right? Left is null, right is null, so we add that to the current path. Our current path to the result. Our result right now, we have 1 to 7, 1 to 5, 9, and it will be added 1, 3, 10, 12. Voila, 1, 2, 10, 12, 1, 3, 10, 12. We return, and we check to the right. Do we have something on the right? No, it's a null on the right. So we will skip that. And then we are done. Because we already check. Why do we return to 1 in here? Because, where's that? So we are from 1 into 3, 3 into 10, 10 into 12, and 12 it has null and null. And this is null. So from here, from 12, we return to a 10. From 10, we already check the left and right is null. We return to 3. 3, we already check the 10, but the left is null. So we back to 1. 1, we already check both of them in here. So we are done. That's how the tree works. And then our actual is expected is 1 to 7, 1 to 5, 9, 1, 3, 10, 12. That's expected. And our result also the same. So it will return true. So same and same, it will return true. Yeah.